All right, yesterday we learned about concentration, and today now we're going to tie how to use that concentration, the molarity, in a stoichiometry problem. So let's deal with our first reaction. We'll do three different examples today. So let's do our first reaction, where we're going to take a piece of aluminum, is added to, let's add it to 50 milliliters of a 0.75 molar hydrochloric acid solution. And we want to find out how many grams of aluminum can react. Okay, so our first thing that we need to do here is we're going to start by writing out our balanced chemical equation. So I like to make sure that we have a balanced chemical equation. Let's see, this is aluminum. We're adding it to our hydrochloric acid. And it looks to me like this is going to be a single replacement type of reaction. So let's start by putting our aluminum out here. Okay, we're going to have that as a solid. It's going to react with our hydrochloric acid. Hydrochloric acid is HCl. When it reacts, we're going to have the aluminum switch places with the hydrogen. So hydrogen is going to be a diatomic gas. That will come off. And we're going to be left with that aluminum chloride. Now the aluminum chloride should be an aqueous solution. So we're going to have AlCl3. Okay, and then we just need to balance it. So I have 3 here. I'm going to have, if I have a 3 here, I know I'm going to end up getting an odd number here. So we're going to have to do this where we're going to put a 2 here and a 2 there. We're going to make a 6 there and a 3 there. So there's our balanced chemical equation. Now what I know is I'm starting with 50 milliliters of that 0.75 molar solution. And I want to find out how many grams of aluminum can I do. So here's my game plan to solving this. We want to use this information, okay, to figure out our moles of HCl. Once we know the moles of the HCl, we can then do a mole-to-mole ratio to get the moles of aluminum. And then once we know that, we can go into the grams of aluminum. So this is kind of our stoichiometry process. So we need to start by first figuring out our moles based on our concentration. Now remember, molarity is the moles of our solute over the liters of our solution. So this volume needs to be converted, and we just need to bring this up. So to find our moles of HCl, we just need to take our concentration and times it by the volume, but I'm going to switch this into liters. So 1, 2, 3. And that's going to give us our moles. Now let's grab a calculator and do our calculation. Alright, so I've got 0.75. I'm going to times that by 0.05. So the moles of the HCl is what I have here. So now I can start to do my stoichiometry step. So I'm going to start with my 0.0375 moles of HCl. And then we're going to go directly into our mole ratio. So this is going to be our moles of HCl to our moles of aluminum. and the reaction is a 6 to 2. And then we do our moles of aluminum to grams of aluminum. And this is where we just need to use our periodic table. To find our molar mass of aluminum. All right, aluminum right there is 26.98. And then we can grab our calculator. And do our calculation. So our 0.0375 times 2 divided by 6 times 26.98. This is grams of aluminum. Now we need to check what was, let's see, 3 and 2. So this one would have been 1, 2, 2, 2. So 0.34 grams of aluminum. And there you go. So just to kind of recap, balanced chemical equation, we went through and used the information about concentration to figure out our moles. Once we knew that, we just did a regular stoichiometry problem. All right, on to problem number 2. All right, so let's say that we have, this time we're going to go with, we'll have 5 grams of magnesium with is reacted with 0.25 molar copper 2 chloride. And we would like to know how many liters will be needed to completely use all of the magnesium. All right, so again, we need to have a balanced chemical equation for this. So we've got our magnesium that's going to react with our copper 2 chloride. So again, this one looks like we've got another single replacement reaction. So we've got our Mg reacting with our CuCl2. And again, this was a solid, this is aqueous. And that reaction is going to be single replacement, so the copper is going to come out as a solid, and then we'll get some magnesium chloride. Okay, we need to make sure that it's balanced, but it does look like it's already balanced, so that's going to be an easy step for us. Now, what we know is we have 5 grams of the magnesium, and we know that the solution we're reacting it with is this concentration. What we want to know, though, is how many liters. So this is one that we're going to kind of work in a backwards from what we just saw. We're going to make sure that we take this, convert this to moles. We're going to do our stoichiometry step to get the moles here, and then we can use this to figure out our final answer. Okay, so that's our kind of path that we're going to follow. So I'm going to start by taking our 5.0 grams of magnesium. We're going to do a gram to mole conversion. So 24.31 grams of magnesium to 1 mole of magnesium. Once we know that, then we can go 1 mole of magnesium to 1 mole of the CuCl2. And we're going to stop there because we just need to get things in moles. So 5 divided by 24.31 times 1 divided by 1, so this is 0.205667. This is going to be my moles of magnesium. Of course, I should probably round this to 0.021, but we'll do the rounding at the end. So that's my moles of my solute. So this is my oh, it's not magnesium anymore. Hold on. It's really CuCl2. There we go. So this is our solute. It's in our solution, and this is the concentration. So our molarity, remember, is the moles over the liters. So if we want to find the liters is really the moles over the molarity. Okay? So that's just doing a cross multiply, so bring the liters up, bring the molarity down. So now we can just take this divided by our concentration. So we'll divide that by 0.25, and we get an answer of 0.82 liters of CuCl2. So that's how much we'd have to measure out if we wanted to use up all of our magnesium. Okay, I've got one more example for us to go through. Let's take that last one here. So in our last example, we're going to do a mixing of two different solutions. And we want to figure out how many grams of precipitate will we form. So let's write out our problem. So we have, we're going to take 25.0 milliliters of a 1.5 molar sodium phosphate. Solution is mixed with an excess of zinc chloride. Solution. We want to figure out how many grams of precipitate will form. So this is like in a lab setting, we basically run this through a filter paper and we would collect that precipitate and then we'd mass it out in the end and see if we did a good job. So first thing we have to do, again, balanced chemical equation. So let's go ahead and write out our balanced chemical equation. We know we're using the sodium phosphate, and we're mixing it with our zinc chloride. So sodium phosphate, NaPO4. This is an aqueous solution. It's reacting with our zinc chloride. Again, an aqueous solution. So this is going to be a double replacement reaction. The sodium's going to bump the zinc. The zinc's going to go together with the phosphate. Really what this is it's going to be ionic ions exchanged. And so we're going to have some spectator ions. And the sodium's going to act as a spectator ion, and the chlorine's going to act as a spectator ion, because the sodium chloride is going to remain as an aqueous solution. So we're going to get that NaCl, which is soluble in solution, so that would run through a filter paper. And then our precip will be our zinc phosphate. We're going to need 2 of those and 3 of those. and this is going to come out as a solid in our reaction. So this kind of ties back into that whole ionic equation and figuring out which one's going to be the solid in the reaction. So now once we've got this set up, I like to go through and list out what we know. So we know that we're going to use 25.0 milliliters of this, and it's a 1.5 molar solution. And what we want to know is, we know that we've got excess of this, so we don't have to worry about that one. How many grams of this will we make? So again, the process is going to be kind of the same. We're going to take this, figure out our moles. We'll do our mole ratio, and then we're going to get our grams to moles. So we did not balance our equation yet, so that's going to be our first step. We need to make sure that this is balanced. Now I've got 3 here, and I've got, whoa, hold on. I'm going to need the phosphate. Oh, hold on. Let's make sure our formula is right. This was a +2. This is a -3. This should be a 3 and a 2. Some of you are probably screaming at him, no, he's got the phosphate wrong. All right, got that fixed. Let's go through and balance it. So I need 2 of those. So I'm going to have to put a 2 there. I need to have 3 here. So now I've got 6 and 6, so I'm going to have a 6 there. So now it's all balanced out. We're going to start with our 25 milliliters, so that's our volume. So if I do my concentration, my molarity, times my volume, that'll give me my moles. Okay? That's what we did with this last problem over here. Okay? Remember, liters times our molarity will give us our moles. So we're going to take our 1.5 molarity times our 0.0250 liters. So I did switch that into liters, and we'll get an answer. So our 1.5 times our 0.025, 0.0375. That'll be our moles of our Na3PO4. Okay. Now, once we have that, we're going to do our mole-to-mole ratio. To our Zn3PO4 2, which is a 2-to-1 mole ratio. And then we just have to do our grams to moles. So 1 mole Zn2,3PO4 2 to grams, Zn3PO4 2. And we need a molar mass of the zinc phosphate. All right, and that is 386.11. So once we have that, we can now do our calculation. So we're going to take our 0.0375, divide that by 2, times that by 386.11, and we'll get our 7 point, now again, I'm going to go to 2 sig fig, 7.2 grams of zinc phosphate. Okay, there we go. So again, there was 3 examples of how we can use concentration to do various stoichiometry problems. If you have any questions as you're doing your practice, just ask in class.